हेलो हेलो गाइस। सो प्रोजेक्ट अपना स्टार्ट करते हैं, टाइम सीरीज फोरकास्टिंग यूजिंग टाइम सीरीज मॉडल। सो इसमें बेसिकली हम अलग अलग मॉडल्स के बारे में पढ़ेंगे। उनसे हम आगे के फ्यूचर पॉइंट्स, हम फ्यूचर प्रिडिक्ट कर सकते हैं। लाइक व्हाट इज द बेसिक ऑफ time series is that we have given some data sets, means like a stock price. You have given for a particular stock, we have given the prices, like how it varies. So like in future, and we need to predict from this past data how the stock prices will affect in future. So we will use time series model. So we will analyze how the trend is going on. Is there any seasonal factor in that stock prices, and how there is a you can say like probability factor, means which is nowhere related. We can't predict some error term related, which some minor error which we can't predict. So we have to take it otherwise. And there are trends, seasonal factors, which we have to keep in mind. And we will use our time series knowledge to predict the future price. And this can be, there's various examples where we can use this knowledge of time series. Like I gave an example of stock prices. Otherwise, you can use also in mm, weather forecasting. So like, and so yeah, and let's go to text. So in this, we will use the programming language Python. Libraries will be Pandas, Stats Model, uh, Arima and Sarima, and TensorFlow. So tools we will be using mainly will be Google Colab. If you there is some problem, or if you are more familiar with Jupyter Notebook, you can go with it. But I will suggest like Google Colab will be a better option. So yeah, so we will I will give you a brief introduction how our project will go on. So basically, what we will do, like every project we do in IITK, we will just give an introduction in this video about what we will do in week one and week two. So we will give you an introduction, then we will share the resources. We want you to watch all the videos and understand the concepts. We will just give a basic introduction what we will do in the next week. So after you watch the video, we will share a doubt Google form where you can write all the doubts related to the videos you watched. And if you have any doubt, we will also share you an assignment in which you have to complete to get the ratification. And after the completion and all the videos watched, we will have a doubt session in which you can ask your doubts. We will share a Google form on the Discord where you can write your doubts, so we can discuss in the next meet. So yeah, this is the project we will go on, like week one, week two, in this way, and finally in the week, most probably in week four, we will wrap up all our project, and we will have a final evaluation for your ratification. And nothing, if you have knowledge of MSO 201 or HSO 201, it's very good. It will be very helpful for you. But if you don't have, we will share all the resources related to that you don't need to worry. If you have knowledge, well and good. If don't, nothing. Like yeah. So, uh, so let's start with the slides we have prepared for the introduction of this week one. Yeah. So in this slide, in this introduction video, we will cover the basics of provided stats, which will be useful for you. So we will give you, as you know, we have shared all the videos like on the expectation value, probability stats, what is CDF, PMF function, and I hope you all have watched the video. We just given brief introduction. If you haven't watched the video, please watch it. It will be compulsory to watch all the videos. Yeah. So basically, first we'll start with what is the difference between the probability and stats. So probability is dealing with the predicting or getting a idea, like you all learned in the J advanced. Probability is nothing but predicting the chances of outcomes. Like you throw a dice, what is the probability of coming a six? You know, if you throw a normal dice, probability of getting a six is 1/6. Probability of getting two is 1/6. Similarly, this is a probability. And like you can see the example calculating the probability of rolling a specific number on a fair six-sided die. So this is a probability. And stats is a different thing. stats is like we collect the data points, we interpret, we organize, we will we try to get an idea about the raw data set. We have a raw data set, we first need to collect this, and then we have to get a idea about the future or how can the previous data could be beneficial to make future plans. So in big companies like Instagram Reels or Amazon, you have seen the recommendation you get on the Prime and the Netflix. It uses the stats, but you have previously seen and how you like to watch in future. Like if you watch suspense, then Netflix will show you the more suspense types movies. So this is the application of stats, and you can see I have given an example of Amazon. So yeah, this is the basic difference between the probability and stats. So let's move to the next slide. So in probability, like we have two events, two types. Basically, a terminology in probability which will be very useful. So there is one term called mutually exclusive. If event A and B are mutually exclusive, it means the probability of occurring A and B together is zero. So like you throw a dice and you are asking like event A getting a even number and event B is getting a odd number. So these are completely different. They can't occur simultaneously. So event A and event B are mutually exclusive. That is probability of A and B occurring together is
Terminology is known as mutually exclusive. Now we have a independent term. So if applying the condition B does not affect the probability of A, then we say A and B are independent events. So let me give an example. Like you throw two dices, A and B dice. So if you say event A getting one on dice A and event B is getting two on dice uh, two on dice B. So there's no relation between the two dice. Means if you throw the if you get two four on the second dice, it doesn't affect any probability on the first. Three on the second dice, even then the probability of getting 6, 1, 2, 3, and anything number on the dice one is also 1/6. So event B doesn't affecting anything on the A. So these are mutually independent event. So let me give an example of uh, dependent event. So if there is any correlation between if there is relation between A and B, then they are not independent. So like if you throw two dice, I say if number B is we like event A is getting a or getting the sum of two dices is odd, and if B we get an odd number, so it will be a relation that the number in the die A should be uh, even or odd according to the given condition. So this is the dependent. There is a relation between them. Like we get examples are sum of two dices, multiplication, and something like that. So we are giving a relation. But if they are independent, there is no relation, so they are called independent. Yeah, next slide. Yeah, next. Huh. So we have in probability, you will always come through a random variable term. So what is random variable? So random variable is just you assign a number to the some probability thing. Like you say, like I will give you an example of there are two types of random variable, discrete and continuous. Let me give you an example of discrete variable, random variable to get a much clearer idea. So you will just assign a number to some term. So like you say you throw a dice, then x is equal to 1. It means getting some getting 1 on the upper face of the die after you throw. So x is equal to 1. X is a random variable. So what is the probability of x equal to 1? Is 1/6. X equal to 2 is 1/6 again. So in this you see like x is a just a random variable. You assign a value, like you just call the term getting value 3 or getting value on the upper face of the dice. You just say it you just call it a variable x. So this is a variable whose value is unknown to the function. So you say x is equal to 2, probability is 1 by 6, x equal to 3, probability is 1 by 6. And this is a discrete. It is not a continuous. So like x is equal to 2.1, you can't get a 2.1 sum or 2.1 on the die. So this is a discrete. You have only 1, 2, 3, 4, 5, and 6. With 6 outcomes. So this is a discrete. But and you can have a continuous. You have a lot of examples like Poisson's or normal distribution. These are example of continuous random variable in which the mm, range is a continuous. So you have an interval, not a discrete. Like in the case of dice, you have discrete 1, 2, 3, 4, 5, 6. But in continuous, you have a continuous. You have an interval like 1 to 2 or 3 to 5. This is an interval. So it is a continuous. So in discrete, the probability is uh, in discrete form, and continuous, there is the probability is distributed over an interval. And CDF is applicable for describing the distribution of random variable, either it is discrete or continuous. So just you can what you can learn. We have shared the videos. You have to watch this to get a much clearer idea. But what is PDF is for discrete part, and oh sorry, PMF is for discrete and PDF for continuous part. Yeah, move on. As I give example, or I am telling about the normal distribution, it is an example of continuous random variable, and its PDF function is represented by fx is equal to 1 upon under root 2 pi sigma square exponential minus x minus mu whole square upon 2 sigma square. In this, the sigma and mu are the two parameters. So it is just fx is representing the probability of a particular, like if you put x equal to 2.1, it's representing the probability of uh, is representing how much likely x equal to 2.1 is going to be. So if you and the range of x is minus infinity to infinity. So if you integrate over all the interval, like if you integrate fx dx over minus infinity to infinity, you will get 1 because it's a probability. And so hmm, so this is the PDF function of the normal distribution. Then we have expectation value. We have also shared the video of expectation value to get a much clearer idea. The expectation value you use to calculate the average over all the quantity. If you have given a PDF function, you can use the uh, expectation value idea to get its mean value. Mean value is averaging. So what if you have given a probability or probability PDF function, what will do to get an average? Like if you have a number 2, you know the probability of getting 2. Then like I will give you an example of discrete. Then you can you can correlate it with the continuous expectation value. Like if you have a dice which have only two numbers, so like 1 and 2, and the probability of getting 1 is 1 by 4 and getting 2 is 3 by 4. So if you were asked what is the expected value when you throw a dice, so expected value of this will be 1 into 1 by 4 plus 2 into 3 by 4. So probability of getting 1 is 1 by 4 plus 2 into 3 by 4. It's you can calculate it's 6 by 4 plus 1 by 4, it's 7 by 4. Okay, so in this way you can calculate the average and what is the expected value when you throw dice. Okay, and then in the similar case when there is continuous, you can what we have doing in the discrete, you can do in the same thing. Like you are multiplying the value x, but we are getting like I multiplied 1 with 1 by 4. So x is the quantity we are getting, and we are multiplying it the probability function, which is 1 upon sigma upon root 2 pi exponential term, and we are integrating over the whole interval minus infinity to infinity. you can see the substitution, and then we are getting the expected value of normal distribution as mu. So mu is called the mean of the normal distribution, and later you will know that sigma is the standard deviation. I have also shared the video of the variance you can see, and you can see that sigma square is the variance part. Now we will go to the states part, which will be covered by the Aditya. So Aditya, you can move on.
Okay, so guys, what's stats? Stats is just a collection of an organization, analysis, and presentation of a data in order to obtain some useful results from it. So, uh, stats, the first part of stat is measure of tendency, and measure of tendency, central tendency is of three types: mean, median, and mode. So let us consider exercise to be number of observation. So here the average of all the observation will be the mean, that is sum of all the observation divided by number of observation. Uh, Next, we move on to median. Median. So if you arrange the number of observation xi's in either increasing or decreasing order, so the middlemost element of the observation of the series, the middlemost observation of the series will be the median of the data. Mode. And mode is the observation in the xi series which have the highest chance of occurrence. That is the observation which is occurring with a maximum frequency. That is the highest frequency. And the relation between these three measure of central tendency, that is mean, median, and mode are mode is equal to 3 median minus 2 mean. And range, as all of you know, that range is just simply the maximum observation minus the minimum observation. Range and quartiles. So range is covered as maximum observation minus minimum observation. So what are quartiles? So if you arrange an observation xi, x1, x2, x3, x4, and xn, so on, in either increasing or decreasing order, so the observation which is overall one-fourth of the total observation is called the quartile. That is, if you arrange 100 total 100 number of observation in either increasing or decreasing order. So the one-fourth of the 100 part, that is 25th observation, would be called the first quantile, and 75th would be called the third quartile. If you count on this, you would find out that mean is also part of a quartile, which is the second quartile. Similarly, percentile, as we all have calculated during a JEE days, that is, it's 1 by 100 part of the total number of observation given. Uh, so there are three types of skewness: positive skewness, negative skewness, and no skewness. So positive skewness occur when, well, according to the data, positive skewness occurred when most of the number of observation shift towards the left hand side. And in this case, mode would be the maximum, then followed by mode would be the smallest quantity, then followed by median, and in then it would be mean. And in positive skewness, the right hand side of the normal distribution curve would become a flat surface, which is exact opposite in what happens in the negative skew. The left hand side of the tail of the normal distribution curve, left hand side, becomes flat, and in this case, it would be opposite to that of the positive skew. Means that is, mean would be lesser, followed by median, and maximum would be the mode. And in no skew, all the left and the right tails are almost symmetrical to each other. And for this case, the symmetrical case, mean, median, and mode would all be the same. Variance. Variance is nothing but the spread, how a data is spread across the mean. That is basically, it tells about that how much distance is basically a data is from the central moment. That is the mean. And this variance is calculated by the formula summation of xi minus xi bar ka whole square upon n minus 1. And in this case, x bar is just the mean. Uh, and sometimes variance is also called the second centralized moment. Moment would be basically we, you would basically find out in the video that's what is moment. Uh, and variance and standard deviation. Standard deviation is also one of the way for calculation of spread of the data and is somewhat related to variance as or by the relation standard deviation equal to under root variance. So we go on to the next slide, which is coefficient of variation. Coefficient of variation is normally takes the standard deviation into account and is given by the formula standard deviation upon mean. So coefficient of variance is directly proportional to the standard deviation. And the next we go on covariance. So let us consider the two random variable x and y. And if you want to find out that how these two random variables are related to each other, whether they are related directly or inversely proportional. So you just calculate out the covariance between the two variables and you can find out the relation between these two variables. And covariance can be calculated out by the formula given right in the figure, which is stated as sigma xy is equal to summation xi minus xi bar yi into yi minus y bar upon n minus 1. And here n is the total number of observation, xi is the each observation of random variable x, and yi is similarly the observation of the random variable y. And x bar and y bar are respectively the mean of the observation of random variable x and y. And correlation. Correlation is just simply used to find out the strength of the relation between these two random variables. Whenever you have to find out the strength of a relation, you just use the correlation formula, which is stated as rho xy and which is given by sigma xy upon sigma x sigma y. Here, sigma xy stands for the covariation between the two random variable xy, and sigma x sigma y are respectively the standard deviation of x. So, as in the previous video, we were discussing about what is correlation. Correlation is when a two random variable xy relation is determined by the covariance. So that relation is so to find out the strength of that relation, correlation is used. And correlation formula xy is calculated as rho xy equal to sigma xy upon sigma x sigma y, where sigma xy stands for the covariance, which is calculated as by the formula given mentioned here, divided by sigma x sigma y, where sigma x is the standard deviation of the random variable x and sigma y is the standard deviation of random variable or particular y random variable. Um, so here comes to the end of the statistics part.